Astronomers using the Hubble Space Telescope have deduced the presence of an extremely massive core in the distant galaxy M87. It is so dense that it could be a black hole, where no light escapes. They did this by measuring the speed of gas clouds orbiting the core to be 780 kilometers per second at a distance of 60 light years from the core. We want to deduce the mass of the core and compare it to the mass of our Sun. So to answer this problem, we need to recall that when an object is orbiting around another object, then the orbiting object is at the escape velocity, where the escape velocity is equal to the square root of the mass of our central object, so here our core, the black hole core, times the gravitational constant g, divided by the radius, this distance between the orbiting object to the core. And we want to solve for the mass of the core, so let's rewrite this equation and solve for m. So the mass of the core will be equal to the orbital velocity squared times the radius divided by the gravitational constant, where in our problem we have the velocity is equal to 780 kilometers per second. The radius, or the distance separating the orbiting gas clouds and the core, is equal to 60 light years, which corresponds to 5.7 times 10 to the 17 meters. And the gravitational constant g is equal to roughly 6.67 times 10 to the minus 11, with units of meter cube, kilograms minus 1, and seconds minus 2. So now we're going to have to be a little bit careful of units here. Let's transform the velocity here into meters. So this will be equal to 780 times 10 to the 3 meters per second. Now we're ready to calculate the mass. The mass will be equal to 780 times 10 to the power 3 meters per second, all this squared, times the radius, 5.7 times 10 to the 17 meters, divided by g. 6.67 times 10 to the minus 11 meter cube, kilogram minus 1, second minus 2. And we'll see that all of our units will cancel out except for the 1 over kilogram minus 1, giving us a result of 5.196 times 10 to the 39 kilograms. So this is the mass of the core, and we want to compare this to the mass of the Sun. So the mass of our Sun is equal to 1.989 times 10 to the 30 kilograms, which means that the mass of the core, the black hole core, is equal to roughly 2.61 10 to the 9 solar masses, which means that the mass of our core here is roughly 2.6 billion times more massive than the mass of our Sun in a very small radius, which means that we have dealing with a very dense object, which will likely be a black hole.